Okay, page 1079, General Hazardous Material Behavior Model. Add this, write this down because you might see it abbreviated as this, GEBMO, which is GEBMO, GEBMO, and that is the General Hazardous Materials Behavior Model. This is an uncontrolled release from a container and can expose people, animals, and the environment to many hazards. When first responders collect information about the physical and chemical properties of released hazardous material, they can determine the presence of hazards, estimate potential harm, and predict how the incident may progress. The same material, physical, and chemical properties that create hazards upon release will influence how a container will behave when damaged or ruptured. First responders need to know how to account for these factors when attempting to understand the problem posed by a hazard incident. In order for first responders to protect themselves and others, they must understand how a hazardous material and its container are likely to behave in any given situation. Know that. We're going to move down to the common sequence that generally occurs. So, I'm going to back up just a minute. Model assumes that hazardous material incidents have following a common element: material or materials presenting hazardous to people, the environment, or property, containers that have failed or potentially failed, and exposure to people, environment, and or property. So, common sequence generally occurs, and this is in order. This is the first step. So know this. You're going to have to know each one of these six steps that I'm just going to go through briefly, but you're going to have to write it down or highlight it, whatever you need to do. Stress. Understand that stress is the container undergoes physical or thermal or other types of damage that reduces its ability to function and leads to a breach or a failure. So stress can just be a dent in a tank. That is stress. Breach. The container becomes open to the environment. You remember whenever you were doing your forcing yourself through a wall, you breached the wall, you made a hole. So understand the term breach is opening up. So first of all, it was stressed. You hit something and put a big dent. That dent now became a puncture and it breached. Now you have release. When the container breaches or fails, the contents or the stored energy and pieces of the container may be expelled into the environment. So now you have a release. A dispersion or engulf occurs at the hazardous material inside the container or any stored energy release and move away from the container. This is where, like the vapors, will start moving away from the container. That is the dispersion. And there are certain patterns that we're going to have to know in the dispersion patterns. Exposure. Anything, persons, or environment that is in the area of the release and exposed to the hazard. And then the harm. The harm, depending on the container of the hazardous material, the energy involved, exposures may result in the harm or damage. So let's just recap this. First of all, the container gets stressed. Then it breaches, it opens up. It releases the product, and then it just starts dispersing, moving away from the actual tank or whatever it could be. Then it comes in contact with somebody, and then that could be upon contact whether you're going to be harmed or not. So make sure you know that. Let's look at stress. The container stress is either caused by, know this, it's either going to be thermal, chemical, or mechanical energy. So some of the things on thermal, and we know that thermal is either heat or cold. The container undergoes excessive heat, may be close to flames, undergoing the operation of a relief valve, or know this, if its containers under heat, know this, making noises of expansion or contraction. Container that is succumbed by cold may be excessive frosting, visible cold vapors, or changes in the steel structure, or you could have pools of cold liquid. Chemical energy, uncontrolled reactions of the container and its contents. The chemical reactions could result in the following. So we have to know this. We have to know that chemical reactions could be sudden or long-term deterioration of the container, excessive heat and or pressure, corrosive and other incompatible interactions between the hazardous material and the container of the material. Know that it also can be visible corrosion and or degradation of the container surfaces, including, know this, bulging, cracking, and or popping noises. Know that. The interior of the container may experience chemical stress with no visible indications from the exterior. Mechanical energy. Physical application of the energy could result in the container attachment or damage. The mechanical stress may change the shape of the container, reduce the thickness of the container surface, crack or produce gouges, unfasten or disengage valves and piping, or penetrate the container wall. Now moving on to breach on page 1082. Breach. When a container is stressed beyond its limits of recovery and it opens up or breaches and releases its contents. Let's just go to the types of breaches. You're going to need to know the difference in these. You will see it again. Disintegration occurs in containers made of a brittle material. The container suffers a general loss of integrity. Runaway cracking breaks container into two or more large pieces, fragmentation, or large tears. The crack develops and continues to grow rapidly. Runaway cracking often occurs in closed containers, such as drums or tank cars. And you definitely need to know this, that runaway linear cracking is commonly associated with blevies. Know that. Attachments open or break, may fail, open, or break when is subject to stress, leading to a total failure of the container. A puncture. A puncture occurs when foreign objects penetrate through the container. A split or tear. Containers may breach through a split, such as a welded seam on a tank or when a drum fails. May be caused by mechanical or thermal stressor. Release. This is when the container fails and its contents or energy of the container itself may release. Depending on the situation, this release can occur quickly and over an extended period of time. Generally, large amounts of stored mechanical energy results in a more rapid release, presenting a greater risk to first responders. So, releases are classified according to how fast they occur. Again, more things you're going to have to know. You have to know what a detonation is. A detonation, explosive release of stored chemical energy of a hazardous material. The duration can be measured in hundreds or thousands of a second. An example could be an explosion. The release could result in fragmentation, disintegration, shattering of the container, or extreme overpressure. A violent rupture. A violent rupture is immediate release of a chemical or mechanical energy caused by runaway cracks. You have to know that. Time frame 1 second or less. Example would be a blevy, runaway cracking, violent rupture, blevy. Rapid relief. No, rapid relief, fast release of a pressurized hazardous material through properly operating safety devices. May occur in a period of several seconds to several minutes. Know that a rapid relief could result from damaged valves, damaged piping, damaged attachments, or holes in the container. A spill or leak is a slow release of a hazardous material under atmospheric or head pressure through holes, rips, tears, or unusual openings in the attachments. Can last for several minutes to several days. Okay, so again, recapping that, you must know the difference between a detonation, a violent rupture, a rapid relief, and a spill or leak. Dispersion and engulfment. Disbursement of a material is sometimes referred to as engulfment. Dispersion of a hazardous material, energy, and container components depend on the type of release, which include a solid, liquid, or gas vapor, mechanical, thermal, or chemical energy, and ionizing radiation. Add this to dispersion. You might see it's called dispersion and engulfment patterns. So next to dispersion engulfment, write patterns, because that might be something you'd say dispersion patterns or engulfment patterns. So just know that's the same. Common dispersion patterns include, and you guessed it again, you're going to need to know these, and these have been known to be on some of your state tests. So definitely read over this. You must know this. No, hemispheric. Hemispheric is a semicircular or dome-shaped pattern of an airborne hazardous material that is still partially in contact with the ground or water. Make sure you know that. I'm not going to read over everything. I'm just going to read over, you need to read over the rest of it. A cloud. A cloud is a ball-shaped pattern of the airborne hazardous material that collectively rises above the water or ground. Ball-shaped pattern. A plume. A plume, irregular shaped pattern. Irregular shape pattern of an airborne hazardous material where the wind and or topography influence the downrange course from the point of release. Okay, irregular shape pattern. And the two different types of plume would be a puff release or an ongoing release. A puff release is when materials is released at one time, to an ongoing release, which the concentration increases over time. Make sure you know the difference in those two. A cone. A cone is a triangular shaped pattern of a hazardous material with a point source at the breech and at a wide base downrange. A stream is a surface falling pattern of liquid hazardous material that is affected by gravity and topography contours. A pool. A pool is a three-dimensional, slow-flowing liquid dispersion. Liquids assume the shape of their container and pool in low areas. Irregular. Irregular is irregular or indiscriminate deposits of hazardous materials such as that carried by contaminated responders. Okay, now just kind of going back over this real quick. The different patterns, you know, from a hemispheric, a semicircular, or dome-shaped pattern, you have to know the difference in those patterns. And you also need to know the difference whenever you get into the different types of hemispheric energy, dispersion, or release. But what I was getting at is there's also, you can, if you need to, there are examples on the figures. So you can look at the hemispheric release. It gives you an example on figure 2461. And then there's an example of a cloud and a plume. But make sure, and the reason I'm telling you this is you may just have a picture and it's going to tell you which dispersed pattern is this. And you're going to have to look, and if it's a cloud, you're going to have to look and go, that is a cloud. And that would be the correct answer. So not only know the term and which sort of what the pattern looks like, but also look at those pictures on your figures, because that might be the actual question. Would be looking at the picture and then coming up with the answer. Here's some things I want to talk to you about real quick on page 1090. In the event of a release, a facility pre-incident surveys may contain plume dispersion models to help estimate the size of an endangered area. Know this: some of the software that you can use for a plume dispersion model, know this, you're going to see this again, would be something called a computer software, CAMEO. CAMEO stands for Computer-Aided Management of Emergency Operations. Know that. That is a software that is used in a plume dispersion model. Along with that, you would use something called ALOHA. ALOHA is an area locations of hazardous atmospheres. Area locations means ALOHA brings up a area, so it's kind of like a map, and so you can see the map, and that combines with CAMEO, and then you can plume and predict where your plume is going to go and what's along the way. Do you have schools? Do you have businesses? Those sort of things. So those combined will help you plume your model, and so that way you would know where to start whether you're going to evacuate or shelter in place. So understand, CAMEO along with LOHA are computer softwares that you can use to plume your dispersions. Exposure contact: as a container releases, its risk dispersing its contents in the container itself on different types of exposures, people, and the environment and property. In some cases, you can use your emergency response guidebook to estimate the size of the endangered area. In some hazardous materials, you may present a threat to one specific exposure type, and others present a threat to all types. Now, consider the following exposures in hazard and risk assessments. People includes responders and others in the path of the hazardous material. The environment is the air, water, ground, and other life forms. The potential effect to the environment varies with the location in which the product is released. Property, that includes things threatened directly by the hazardous material or the energy at the time of the release. Contacts, impingements, are associated with the following general time frames. You must know these time frames, and you will see these time frames again, I guarantee you. Immediate milliseconds, seconds. That could be anywhere from the deflagration, explosions, or detonation. Short term, minutes or hours. Medium term, days and weeks, and long term or years. You must know those, A, B, C, and D. You got to know the difference between immediate, short term, medium term, and long term. Harm. Harm is defined as injury or damage caused by exposure to a hazardous material. 3 mechanisms of harm in a hazmat incident, and that's going to be energy, corrosivity, and toxicity. Make sure you know those 3 mechanisms of harm. Okay, I'm going to do the 7 clues to the presence of hazardous material. All right, 7 clues to the presence of hazardous materials. Awareness level personnel and first responders must be able to analyze all incidents in order to detect and identify the presence of hazardous materials. Incidents involving hazmat can be controlled only when the personnel involved has sufficient information to make informed decisions. Time and effort devoted to identify the contents of the buildings, vehicles, and containers result in greater safety for first responders in the community. Failure to recognize hazardous materials at emergencies has caused unnecessary injuries and death. Once the hazmat is detected, first responders can use resources to identify it and its potential hazards. With that information, first responders can initiate appropriate response actions. Okay. So with this, I'm just going to back up real quick. We talked about first responders using your resources to identify what you're dealing with and the potential hazards. Understanding how to initiate the appropriate response actions, and hopefully you can perform those with confidence. Remember, when we're dealing with hazmat, we not only try to identify, but we also try to verify. And along the way, if it has any sort of markings, we can classify. So, 7 clues. And just know that when we're dealing with these 7 clues, we're going from the least risk, which is the furthest away, to the most risk. So let's go over the 7 clues. The occupancy types, locations, and pre-incident surveys. So when the call comes in and you've given your location, then that location is a clue to whether or not we may have a hazmat incident. If you're responding to a refinery, it could be a hazmat incident. So that would be the least risk, is just understanding the location. The container shapes. Part of your hazmat, I gave you a handout sheet and it had the container shapes on there. You are going to have to be able to look at a container and identify it by its shape. And you're also going to have to know whether it's let's just take, for example, an MC306 is a non-pressure container with an oval shape. And you must know that. Not only will you have to know that, but you also need to know that it is atmospheric pressure, which is no pressure, non-pressure atmospheric tank, and the maximum amount of pressure might be in there. I think it's 5 psi, something like that. So you must know that, and you also need to know where the emergency shutoffs are on that. So the container shapes. Now, when we're dealing with fixed containers, the tanks, whenever you drive down 37 and you look at the containers out there, you see these large containers. You're going to have to be able to, and it's also in your handout, you have to look at those fixed containers and be able to tell, is that a floating roof? Is it a cone roof? Those sort of things, just by the shape of it. So you might as well get started and start trying to identify those particular type of container shapes. Transportation placards, labels, and markings. We're going to go over classifications. We're going to go over placards, labels, and those markings. Other markings and colors. Written resources. We're going to talk about some of the written resources. Could be your shipping papers, and I'll give you that a little bit later. Your senses. Sight, hearing, smell, taste. You do know if you start to smell or taste a chemical, you're pretty close to it. So now we're getting into the most risk. The most risk, which is they have senses, and this resources actually gives monitoring and detection devices as the last or the highest risk per se. But I would say that senses, if you can smell or taste, that you are pretty much in the danger zone as it is. In order for the clues also represent, in general, an increasing level of risk to the responders. So just know, least risk would be the location, occupancy type. And as we move through these, all the way down to senses and monitoring and detection devices, which would be the most risk. Okay. I want to do pre-incident plans. We'll start on pre-incident plans, occupancy types, and locations. All right, hazardous materials may be found anywhere. Not all locations or occupancies are obvious. You may have little or no warning when hazmat is transported through your area, whether it's by road, rail, or waterway. Pre-incident surveys and occupancy types may provide the first clue that a hazmat is involved. Location and occupancy may be an indicator that terrorism is involved. So you definitely need to know that you may have little or no warning when a hazmat is transported through your area. Okay, pre-incident plans. Because hazmat incidents can be quite volatile, first responders may need to make decisions quickly and accurately. Conducting pre-incident surveys, also called pre-plans, and being familiar with local emergency response plans can simplify and reduce on-site decisions. With groundwork laid, first responders can concentrate on the situation and operate more safely and efficiently. Pre-planning reduces oversights, confusions, efforts, and duplications, and results in desirable outcomes. Now, what we also want to add to this is pre-planning. Pre-planning is an ongoing process that includes reviewing surveys and updating those surveys. Pre-incident surveys are not always accurate. Inventories, businesses, and other factors may change without notice. Compliance with existing reporting rules and regulations cannot always be guaranteed. Know this, always expect to find the unexpected. Let's look at some of the occupancy types. Occupancy types could be anywhere from fuel storage facilities, paint supply stores, medical facilities, dry cleaners, lumber yards, print shops, warehouses, list goes on. Those are all the different occupancy types. Locations. We need to know some of these locations. These locations might be hazmat transportation accidents may be more likely to occur in these certain areas. So we need to know some of these areas. Places where hazmat is transferred, handled, are likely locations for hazmat accidents. So I want you to know at least a few of these. So know that you might be a port, a dock or a pier, railroads, sidings, airplane hangars, truck terminals. So you only have 5 of these, so make sure that you know that these are some areas that hazmat might be transferred and handled. I'm not going to go through all the ones, but roadways could be truck routes, blind intersections, railways, depots, terminals, switch yards, waterways, bridges, crossings, piers, and docks. And airways could be anywhere from fueling ramps, freight terminals, crop duster planes, those sort of things. Okay, I'm at the 1096 paragraph above container types. Just know this. When we're dealing with first responders should be familiar with the types of hazmat shipments that come through their jurisdiction. So, for example, make sure you know this. For example, farming communities may be more likely to see tanks of anhydrous ammonia passing through, whereas a port serving an industrial complex with many refineries might see more petroleum products. So just know that anhydrous ammonia is fertilizer versus petroleum products. So you'd have more fertilizers in the farming communities versus petroleum products, which might be in areas where there's a port like we have. Okay, so that's going to wrap up another 30 minutes. And we'll start off again on container types and behavior.